In this video, we're going to take a look at factoring quadratics. And you'll see by the end that factoring quadratics are really like solving these little number puzzles. So we'll start with a couple emoji puzzles, just for kicks. Alright, find the value of each emoji. So we have two emojis that add to 12 and multiply to positive 27. So what two numbers can add to 12 and multiply to 27? Well, how about 3 and 9? 3 plus 9 is 12. 3 times 9 is 27. And note that the angry face could be 3, and the crying face could be 9, or it could be reversed, 9 and 3, right? Doesn't matter. All right, one more. This one's a little trickier because there's a negative. So we have robot plus ghost equals -8, and robot times ghost equals 65. Well, we know that one of these has to be negative because they add to a negative. And we know that the negative has to be 8 greater than the positive for them to add to -8. 8 by 8 greater, I mean, has an absolute value that's 8 greater. So let's actually start, for these puzzles, it's best to start at the multiplication because there's a limited number of ways you can multiply to 65, right? There's actually infinite ways to add to -8, literally infinite. -9 plus 1, -10 plus 2, -11 plus 3, -50 plus 42, -100 plus 92. But there's not that many ways to multiply to 65. So let's see, 1 times 65, that's one way, but those are 64 apart. We need numbers that are 8 apart. Well, 65 ends in 5. How about 5 times 13? Well, 5 and 13 are 8 apart. So now we just have to decide, is it going to be 5 plus -13 or -5 plus 13? And since it ends up as a -8, we know that the negative has to have the greater force, so it's going to be -13 and 5 for our answer. And again, we could switch this around. The robot could be 5 and the ghost could be -13, or the robot could be -13 and the ghost could be 5. So keep these puzzles in mind for later in the video when we get to factoring quadratics. But first, we're going to review multiplying binomials. So here we have two binomials, x plus 4. Binomial means two terms. X is one term, 4 is another. And then in the second binomial, x plus 7, x is one term and 7 is another. So as a reminder, when you multiply binomials, we're going to draw out these double rainbows. And we first distribute the x. We get x times x is x squared. X times 7 is 7x. Then we distribute the 4. We get 4 times 4x and 28. So when we expand it, we get this, x squared plus 7x plus 4x plus 28. Then we add combine like terms, and our final answer is x squared plus 11x plus 28. Now notice something. Do you see how this 4 and 7 relate to the 11 and 28 that are produced when we expand? 4 plus 7 is 11, and 4 times 7 is 28. So when you're expanding or multiplying binomials, this is a pattern you're going to notice. When you multiply the two numbers, you're going to produce the constant at the end, and when you add the two numbers, you're going to produce the coefficient of x. We'll see another example, and I'll go through it a little more quickly. So we distribute out here, we get x squared plus 8x minus 3x minus 24. We combine like terms, and we get x squared plus 5x minus 24. And let's see if the same pattern holds true. It does, because if you look at the -3 and the 8, and you add them, you get 5, which is the coefficient of x, and if you multiply them, you get -24, which is the constant we got at the end of this polynomial. Next example, let's just try to preview. We have a -6 and a 2. So when we expand this out, negative 6 plus 2 is negative 4. That should be our x coefficient. And negative 6 times 2 is negative 12. That should be our constant at the end of the expression. And lo and behold, that's what we get. X squared minus 4x minus 12. Because negative 6 plus 2 is negative 4, and negative 6 times 2 is negative 12. Final example, one where these numbers are both negative. X minus 8, x minus 9. Well, when we add negative 8 and negative 9, we're going to get negative 17x. And when we multiply negative 8 and negative 9, we're going to get positive 72. So now that we've seen that pattern, we're going to use that to factor quadratics. So this is a polynomial that has a special name, which is a quadratic. X squared plus something x plus something. And to factor this, we're going to solve this little puzzle. We're going to think what two numbers add to 11 and multiply to 18. And I would recommend starting by thinking about or listing the factor pairs of 18. Right? There's not that many possibilities for two numbers that could multiply to 18. 1 times 18, 2 times 9, or 3 times 6. So now look at those factor pairs and which factor pair adds to 11. This second one. 2 plus 9 is 11. So we can factor this quadratic and make it x plus 2, x plus 9. We're working backwards to get from the quadratic to a pair of binomials. Second example, x squared plus 5x minus 36. What two numbers add to 5 and multiply to negative 36? Well, to multiply to negative 36, one of them has to be positive and one has to be negative. But let's first just list the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. We know that we're going to need one of these to be negative and one to be positive to multiply to negative 36. And for them to add to 5, they need to be 5 apart with and the one with the greater absolute value is going to be the positive one. So which factor pair here are 5 apart? 4 and 9, right? So now we just have to decide, is it going to be negative 4 and positive 9 or positive 4 and negative 9? And since they're adding to a positive 5, the 9 will be positive. So it's going to factor to x plus 9 times x minus 4. And these two are interchangeable, meaning you could make it x minus 4 times x plus 9 if you wanted. That would also be correct, because multiplication is commutative. You can do it in any order. Next example. We need two numbers that add to negative 16 and multiply to negative 36. Well, again, to multiply to negative 36, one has to be positive and the other has to be negative. So here are the factors of 36. Which factor pair are 16 apart? 2 and 18. So now we have to decide, is it positive 2 and negative 18 or negative 2 and positive 18? And since they add to negative 16, the 18 must be the one that's negative, because negative 18 plus 2 is how we get negative 16. If it were positive 18 plus negative 2, it would be positive 16. So when we factor this quadratic, we get x minus 18 times x plus 2. Next example. What two numbers add to negative 19 and multiply to positive 18? Well, if they're adding to a negative and multiplying to a positive, they must both be negative. Right? A negative times a negative will get us a positive, and it will also add to a negative. So here are our factor pairs for 18. Which two of these could add to negative 19? Negative 1 and negative 18. So when you factor this out, it'll be x minus 1 times x minus 18. Final example. a tricky one because there's no x term. So if we had to have a coefficient for x, it would be 0. So we can think what two numbers add to 0 and multiply to negative 36. And if we put up the factor pairs of 36, we can see that since we need to multiply to negative 36, and we need one to be positive and one to be negative, this final option right here, 6 and 6, would work. If we make it positive 6 and negative 6, they'll multiply to negative 36 and end up adding to 0. So there's our final answer. X squared minus 36 equals x plus 6 times x minus 6. So going back to the beginning, when you're asked to factor quadratics, just keep in mind you're being asked to solve a puzzle where you have to find two numbers that add to the middle term, the coefficient of x, and multiply to this final term that's a constant.